Okay, so we're looking at the exponential and logarithmic functions or log graphs. At this point you had exercise 2 for homework. Exercise 2, yeah. And you had exercise 3 number 1 as well. Looking at exercise 2, any issues here with number 1? Sorry? Exercise 2 number 1. Write these logs in exponential form. Any problems number 2? Number 3? Number 4? So 4.1 is fine. 4.2? 4.2. Okay, let's start there. It says solve x by applying the log definitions and the log definition. Give your answer to 2 decimal places where necessary. Alright. Just this here. Right, so from 4.2, let's close this. Sorry. Alright. So 4.2, we got 3 to the x plus 1 is equal to 25. So is that in the form of a to the x equals y? Yes. So I can write it in log form. So x is equal to log y base a. The base remains the base. Okay. So this would be written as the exponential is going to be x plus 1 equals to log 25 base 3. So x is equal to log 25 base 3 minus 1. Put that in the calculator. So that's log 25 base 3 minus 1. 1 comma 93. Okay. Any problems with 4.3? So you got 15 equals 3 into 1 plus 0 comma 2 to the x. So firstly we must get it in this form of a to the x equals y. So what do I do first? Divide by 3. That's going to give you 1.2x. 1.2 to the x equal to 5. Now it's in that form. Not so. So make x the subject of the formula. X is equal to log 5 base 1 comma 2. Log base 1.2 log 5 base 1.2 gives you 8,83. Okay. Any problems with 4.4? 4.5?
Yes, sir.
So in question 4.5 we got 14 times 2 to the x minus 2 is equal to 15. So is that in the form that it's needed in? No. So what do I do first? Divide by 4. Could I multiply that 14 and that base of 2 there? No, because of that variable exponent. Okay, so divide by 14 first, both sides. So that cancels, so you got 2 to the x minus 2 is equal to, that's going to give you 25 over 7. Not so. Now is it in that form? Yes. So therefore, x minus 2 equals log 25 over 7 base 2. Now I can take the 2 over the equal sign. So x is equal to log 22 over 7 base 2 plus 2. calculator. Log 25/7 plus 2. Going to give me 3,86. 3,84. Okay. And issue the 4.5, 4.6, 4.7, 4.8. Huh? No problem. Okay, nice. 4.9, 4.10. Yes. So here we got log 8 base 2 is equal to x squared minus 2x. The base remains the base, so it will be therefore 2 to the x squared minus 2x is equal to 8. Well, what can 8 be written as? 2 to the power 3. So 2 to the x squared minus 2x is equal to 2 to the 3. So therefore, x squared minus 2x is equal to 3. Bring it over the equal sign, so you get x squared minus 2x minus 3 is equal to 0. Trinomial. So we got x and a 3, x and a 1. 1 plus, 1 minus, the bigger one has to be minus. So the 3 must get the minus. Okay, and plus 1. So we can now say that x is equal to 3, or x is equal to negative 1. Going to give us 3, so that one works. 3 squared is 9. You see, this works out to be 3. Log 8 base 2 is 3. Okay? If you're going to put positive 3 in here, it's going to be 3 squared, which is 9 minus 6, which is 3. So yes, both works. Both work. Okay. Anything else? No, that is the last one. Then you had to do exercise. Then we went on to exponential functions and the inverses. Exercise 3 on page 54. We must still wrap up the trigonometry. Alright, so exercise 3 on page 54. For each graph in question 1.1 to 1.4, draw the graph using the key features of the exponential function. Now the key features are your intercepts and stuff like that. Okay. So when we draw this graph, we use those 3 values: 1, minus 1, and 0. That is suffice to draw these graphs. Okay. So first is draw the graph using this key points of the exponential function. Indicate the coordinates of 3 points on this graph of f and label f clearly. So minus 1, 0, and 1 is enough. It's 3 points really. Okay. So let's do 1.1. I think I'm just going to Assalamualaikum.
Waalaikumsalam.
Apa? Okay. Let's go with 1.1. So you've got f of x equals 4 to the x. The points we're going to use is we've got x and y. This line is broken. Minus 1, 0, and 1. So if I put negative 1 in, I get a quarter, 1 and 4. So if I draw this here, okay, minus 1, 0, 1, 1, 2, 3, 4. So minus 1 gives you a quarter, which is very close to the x. 0 gives you 1, 1 gives you 4. The graph is going to come through like that. Okay, who's going to read first the questions? What's question 1? That was A, no? What was B's question? Use your graph of f of x to draw the inverse function. So what do we do for the inverse function? We interchange x and y. So negative 1 and a quarter becomes a quarter and negative 1. Okay? 0 and 1 becomes 1 and 0. 1 and 4 becomes 4 and 1. So 1, 2, 3, 4 and 1. The graph is going to come again close here. Your y-axis is now your asymptotic. So that is your f of x and this is your inverse function. And always reflected in the line, y is equal to x. Now the sounds that you guys didn't do the homework either. Is that okay? Number 2, draw the line of symmetry. The C's question is to draw the line of symmetry about which f of x and the inverse are symmetrical. This is the line they're referring to there. And D, write down the equation of the inverse function in that form. So what do we do for the inverse function? We interchange x and y. Remember the equation. You have y is equal to 4x, 4 to the x. So we interchange x and y, so x is equal to 4 to the y. So we're going to change that to log form. So y is equal to log x base 4. And that is your inverse function. Next question. That was D. E. Write down the range of f of x and the domain of the inverse function. So the range of f of x and the domain of the inverse function. So you look at the range of f, as you can see here, this graph. Does this f of x exist at negative infinity on your y? No. Where does the graph start existing at? 0 onwards. So we say y is greater than 0. Let's look at the domain of the inverse function, which is this graph here. Domain is all possible x values. Does that graph exist on the negative part of your infinity? No, it starts existing at 0 onwards. So x is greater than 0. If, state whether f and the inverse are increasing or decreasing functions. E, D, E, F. So, what can we say about the f of x? Is it increasing or decreasing? Increasing. How do we know it's increasing? How do we know it's increasing? As we move from left to right. As x increases, we always look at from from negative x to positive x. From left to right. As x increases, what happens to this graph? It's also increasing. That's why it's an increasing function. The inverse function, what can we say? This increasing or decreasing? Also increasing. Why? Because as x increases, the y is increasing. Okay? That's number 1. Point 1. Let's look at 1.2. You're given f of x is equal to a quarter raised to x. Again, A is to draw the graph. If we draw this graph, the key points minus 1, 0 and 1, x and your y. So it will be 4, 1 and a quarter. That's enough to draw this graph. there's minus 1, 0 and 1. 1, 2, 3, 4. It's all about the approximation. Okay. So it's negative 1 and 4. Again, you'd write that in. Zero and 1. It's going to be 1 and a quarter. So the graph is going to come through like that. Okay. It's going through this point of 1. Then the question B says to draw your inverse function. So what do we do? So this is f of x, no? So what do you do for the inverse function? Interchange x and 1. So 1 and a quarter becomes a quarter and 1. Quarter and 1. Okay? 0 and 1 becomes 1 and 0. Negative 1 and 4 becomes 4 and negative 1. The graph again, your y-axis now your asymptote. Okay? This is your inverse function. Alright, and so that is B. C's question was to draw in your line of symmetry, so this y is equal to x. People, this point here is where the two graphs overlap. Okay? That is C. D, the question was to write down the equation of the inverse function. So what do we do for the inverse function? Interchange x and y. So for the inverse, this can be, it will be x is equal to a quarter to the y. So therefore, y is equal to log x base a quarter. Not so. And I've indicated before, this can also be written as what? Okay. I've said it already, I'm sure, but okay, if I didn't, it's fine. It could be written as y is equal to 1 over 4 raised to x, of course, which also can be written as 4 to the minus x. Okay. So you go for the inverse function, you interchange x and y. So we say x is equal to 4 to the negative y. We change it to log form, is negative y is equal to log x base 4, which is also equal to y is equal to negative log x base 4. So this here and that is equivalent. It's the same. Make a note of that because when it comes to transformation, that will catch you out. Okay. And always when they work with the base being between 0 and 1, that question always comes up. Explain the transformation that's happening from f of x to this. And the learner can't make that link between a quarter and the 4. Where's the link? They can't. Okay? That is the catch thing. So look out for that. That's D. Let's look at E. So, what I expected you to have said, this could have been written as negative log x base 4. Okay? I expected you to have said that. But then again, I think I'm expecting too much from you guys, no? State whether f of x and its inverse are increasing or decreasing. So what can we say about f of x? It is decreasing. It's decreasing. Why? So that as x increases, the value of y decreases. That is f of x. G of x, the inverse function is also decreasing. Not so? Both is decreasing. Why? Because as x increases, the value of y is decreasing. Okay. Alright, you guys get the idea? Okay, number 1.3, 1.4 is the same. 1.3 is the same as 1.4. This the values, of course, is different. Whereas 1.2 and 1.4 again is the same. Okay. Again, the values are a bit different, but the shape of the slope of the graph is about, not the slope, but the graph will look similar. to 1.2 for 1.4. Okay. Now we're going to look at log functions, okay, since we have drawn now the exponential graph and its inverse. Now we're going to look at the log functions, okay. Your homework's going to be exercise 4, okay. So you're looking at the example on page 54, or the introduction is basically on page 54. So log functions. We define the log function as y equals log x base a. Now that we know already, okay. Where a is greater than 0, and a is not equal to 1, and x is an element of real numbers. No, x can't be an element of real numbers. X has to be positive. Not so? X has to be positive. So that's a mistake there. Huh? Because if they say x is an element of real numbers, that means you say x can be positive and negative numbers. And if you put that in a calculator, so you got log. So they're saying the base must be positive, so let's choose a positive base, and negative 8 here. So it's an error. So this here, x can't be an element there to say that x has to be greater than 0. Could be equal to 0 as well. So a log of 0 is 1. So, nope. No, log of 1 is 0. Yes. Log of 1 is 0. So x has to be greater than 0. X can't be 0. So also coming back to this here, the exponential form of that, the exponential equivalent to that would be a to the y equals x. And we know that that number must be positive. And we also know that number must be positive. Not so? And a can't be 1. Coming from our previous knowledge of exponential equations. So that's a mistake there, okay. Unit 1, we were introduced to y is equal to log x base 2, or x is equal to 2 to the y, as the inverse of y is equal to 2 to the x. The key features of log functions, all graphs of the form y is equal to log x base a, where a is greater than 0, and a is not equal to 1, where x is greater than 0, has these functions. The x-intercept of 1 is 1 and 1. The x-intercept is 1 and 1. The y-intercept is the vertical asymptote. And that was clear from our previous drawings, that the log graph's asymptote changed to the y-axis. The domain is x an element of all real numbers, where x is greater than 0, and the range is y is an element of real numbers. If a is greater than 0, the graph is increasing, and if a is greater than 0 but less than 1, the graph is decreasing. When you compare y is equal to log x base a and y is equal to log x base a quarter, you will see that the two graphs are the reflection in the x-axis. Or is 1 over 4? It's not 1 over 4, it's 1 over a. Okay. So let's look at the example here. The example on page 55. Use your table to plot the graphs of y equals x log x base 2, or y is equal to x equal to 2 to the y, and that equation. So when I do this graph, when I do the plotting of this graph, you don't have to do it this way, but if you want to memorize all the rules, then you can. Okay. For me, it's just easier to draw the inverse function. So let's say, what's the inverse of the first graph? The inverse will be y is equal to 2 to the x. Not so. Remember now, the function is the log function, and the inverse is the exponential function. What we've dealt with thus far was that the graph given was the exponential function, and the inverse was the log function. Here it's given in the reverse. Okay. The log function is given, and we're working with the inverse function, which is the exponential graph. Why do I go with this? Is because I'm familiar with the solution. Okay, so what we do is, we get our values. What's our values? Minus 1, 0 and 1, which corresponds with half, 0 and 2. Not so? So when I draw the log graph itself, the log graph, for y is equal to log x base 2, then what will the values be? So x and y will be negative 1, 0 and 1. It will be a half, 0 and 2. And those are the values I'm interested in. Okay. So let's go with that graph first. So we got the half. It says 1, 2, 3. So x is half, y is negative 1. If x is 0, why do I got 0? It's supposed to be a 1. If x is 0, if x is 1, y is 0. If x is 2, y is 1. So there is the one graph. That is, your graph y is equal to log x base 2. You all okay with that? Let's look at the next graph. Again, I work out the inverse function. Why? Because I am again familiar with the exponential graph. Interchange x and y. So we got y is equal to a half to the x. X and y. Minus 1, 0 and 1. 2, 1 and half. That's for the inverse function. Am I interested in the inverse function? No. You want the log function. So for the graph y is equal to log x base a half. Is now going to be minus 1, 1 and a half, which gives you 2, 1 and a half. So if x is 2, y is negative 1. If x is why am I making so stuff? Negative 1, 0. If x is 1, y is 0. And if x is a half, I'm messing up those values here. X and y says negative 1, 0 and 1 corresponds with 2, 1 and a half. So if x is 2, y is negative 1. If x is 1, y is 0. If x is a half, y is 1. The graph is going to come through like that. Okay, and this is your y is equal to log x by so on. So what do you notice about the graphs? What do you notice about these graphs? The reflection in the x-axis. Can you see that, people? Of course, also the y is equal to log x base 2 is an increasing function, whilst this is a decreasing function. As you can see, it's dependable on the value of a. If a is greater than 0 but less than 1, which we just read earlier on, then the graph is decreasing. And as you can see, this base is greater than 1. Therefore, the graph is increasing. Okay. As x increases, the value of y increases, which makes it an increasing function. And there's that graph drawn. Okay. So at this point, you should be able to do exercise 4. Okay, so now we're moving on to log graphs and the inverses. I brought the inverse idea already into this to the discussion. No, not discussion. I'm the only one talking, so you guys don't want to talk to me. And this is on page 55. Log graphs and the inverse. If the inverse of the exponential function is a log function, then the inverse of the log function is an exponential function. That's exactly what I said earlier. Not so. We work to the exponential and we work with its inverse, which is the log graph. In the previous example, we worked with the log graph and its inverse, which was the exponential. It comes into play. This is worked example 1 on page 55. Page 55. We are told that if f of x equals y equals log x base 3, find the inverse function in that form. So how do you work out the inverse function? You interchange x and y. Not so. So it's going to be, for the inverse is number 1. For the inverse function, x is equal to log y base 3. X is equal to log y base 3. So if you write this, you make y the subject of the formula, that goes on to the base. The base remains the base. So y is equal to 3 raised to the exponent x. And that is your inverse function. Okay, you all agree with that? Any confusion? No? Number 2. You got y is equal to